let us consider an old-fashioned fairground with a really slow carousel on it. And if we draw it, it might look like this, with a radius of 38 meters. It has a certain angular speed omega, and we might ask ourselves the question how fast it still is if we stop it, if we slow it down for 15 seconds. 15 seconds of slowing down, how fast will it be? In order to answer that question, we need to know how fast it is initially. So let's say it's a really old and slow carousel. With only one revolution over 2 minutes. That means that we have an angular speed omega, which is 2 pi, which is the displacement angle for one revolution, divided by 120 seconds. So 2 pi radians divided by 120, which is 0.052 radians on second. We also need to know at what rate we want to slow down the carousel. The deceleration, d omega on dt, and that may be such that it's uniform. It's a uniform deceleration, and that it takes 35 seconds so that the carousel comes to a complete stop from its original speed. So therefore the rate is 2 pi divided by 120 seconds. That's the speed, the original speed. That's completely slowed down to 0, and this takes 35 seconds. So we divide again by 35 seconds. Altogether we get 2 pi radians divided by 120 times 35 seconds squared, and that turns out to be 0.0015 rad per second squared. So our deceleration alpha equal d omega on dt is equal to 0.0015 rad per seconds. That means the angular speed omega after 15 seconds of slowing down is equal to the original speed 0.052 rad per seconds minus 15 seconds times 0.0015 rad per second squared. This is the time we slow down, and this is the deceleration. So the product gives us the amount of speed that by which the speed is reduced from its original value of 0.052 rad per seconds. If we work this out, we find that that value is equal to 0.0295 rad per second. So that's the angular speed after 15 seconds of slowdown. Not of, but after the slowdown. Now we can also work out what the tangential speed is. If this is again the carousel looking from the top, then we will have a tangential speed, a linear speed v, which is given by the angular speed omega times its radius. Remember, the radius is 38 meters. If we substitute, we find 0.0295 rad per seconds. That's the remaining speed that we just calculated, times radius, 38 meters, and we obtain a tangential speed of 1 0.12 meters per second.